Hey you guys, just wanted to give you a quick video this evening to go over something that a couple of people have asked questions about from the Kinetics unit. I know several of you are trying to finish up the Kinetics and the Thermo sections of the AP Classroom so we can move on and learn our last topic next week. So if you're working on that and if you have questions about this, I wanted to work through a sample problem for figuring out the rate law using the method of initial rates. And so I copied down this data table from the reaction of bromate reacting with bromide and acid to form bromine and water. And so this method of initial rates is one way that we can determine the orders of the reaction with respect to each one of our reactants. And so you'll remember that we can write our rate law as the rate is equal to, well, we can write it a few ways, right? Rate is equal to K, rate constant, times the concentration of our first reactant to the M, times the concentration of our second reactant to the N, concentration of our third reactant, the acid, to the O. And then these M, N, and O are experimentally determined from this data table. So where do we start? Okay, so if we want to figure out the order with respect to any one of these, we need to hold the other ones constant. So for example, if we're looking at figuring out the order of the reaction with respect to bromate, we need to choose a couple of experiments where we can compare what happens, where we can compare two different concentrations of bromate and look at what happens to the rate where we're holding the other ones constant. So let's look at this. So on these first two experiments, bromate goes from 0.1 in experiment 1 to 0.2 in experiment 2. And I don't have to worry about the effect of bromide or of the acid because those are going to be held constant at 0.1 molar. And so the molarity does not change here. So whatever effect that we see on the rate has to be due to changing the concentration of the bromate. And so hopefully this will make a little bit more sense if we work through this together. Okay, so for the bromate, when I double the bromate concentration, what is the effect on the rate? Well, the rate goes from 8 times 10 to the minus 4th molarity per second to 1.6 times 10 to the minus 3. When I look at that, my brain automatically changes that to 16 times 10 to the minus 4th. And then you can see what happened. If you aren't sure, right, put it into your calculator. Take the larger one, divide it by the smaller one, and you'll see that it doubles. Hopefully you guys can do this mental math pretty easily and just can look at those two numbers and compare it and see, okay, I'm going from 8 to 16, and so my rate doubled as well. And so what that means is that whatever I did to the bromate, the same thing happened to the rate, and so it's first order. It's first order for my bromate, right? So when 2 to the m equals 2. When I doubled my bromate, the rate doubled. And so that order is first order for bromate. Okay. And so once we figure that out, we're really through with bromate. So anything else we do, we want to see what the effect of change in bromide is and the effect of change in the acid, but we want to hold the other ones constant. So let's take a look at the bromide. Let me see if I can slide this down. So which two experiments do I need to compare to figure out the effect of changing the bromide concentration? So I can see, right, I've got an experiment 3, bromide is 0.2, so I'm going to compare something to 0.2. So I need to pick the other experiment needs to be one where bromate and acid are held constant. So that would be these two experiments, experiments 2 and 3. Okay, so what does happen? When I go from point 1 to point 2, and what's the effect of my bromide? When I go from point 1 to point 2, I've doubled my bromide and held that constant. My rate goes from 1.6 to 3.2, so my rate doubles as well. And so I can see that it's going to be first order for bromide as well. Oh, my bromate got a little smeary there. Okay. All right, so the last one I need to figure out is the effect of changing the acid concentration. What happens to the rate of the reaction? Slide back down to our data table. What happens to the rate of the reaction when I double my acid concentration? And so you get the idea, right? I'm going to compare which two experiments? Well, not 3 and 4 because these change as well. So maybe 1 and 4. Yeah, if we compare 1 and 4, then my acid concentration, my H plus, goes from 0.1 to 0.2, but my bromide stays at 0.1, doesn't change. My bromate stays at 0.1 and also doesn't change. So what happens? So when I doubled my acid, so 2 to the, what did we call that variable? O? So 2 to the O equals, well, what was the effect on my rate? Let's look. My rate went from 8 to 32. It did not double. It increased by 4. What does that mean? 2 to the, that looks like a 0. What a terrible little variable. Let's call it P instead. So 2 to the P equals 4. So my P has to be equal to 2. And so second order for acid for H plus. Okay, so we're through, except for we need to put it all together and write the rate law, and we can calculate K. So rate equals K times concentration of bromate to the 1 times the concentration of bromide to the 1 times the concentration of H plus to the 2. So my order, the total order for this reaction is the sum of all of those exponents. So it's a fourth order reaction. And we can solve for K. Let's do that. So what does K equal? Of course you're going to be asked to find K, and you're probably going to be asked to find K with the correct units. And so it matters what our units are. All right, so in finding K, we've got molarity times molarity squared over here. And we've got molarity per second on the left side of the equation. So be careful when you're combining your units. So let's do our units first, and then we'll see what our number is. So we're going to have, when we divide to get K by itself, we are going to have molarity per second divided by molarity to the 4th. And so that molarity is going to cancel out, and we're going to end up with molarity to the minus 3, seconds to the minus 1. Or you may split that out into moles to the 3rd. Let's see. How about liters to the 3rd, moles to the 3rd, times seconds. Right? Either one of those would work. They're equivalent. And so K. Sorry, I didn't quite catch. Siri. All right, so K would be equal to 8.0 molarity to the minus 3, seconds to the minus 1. you should try plugging in data from any of the other experiments. Try experiment 2, experiment 3, experiment 4, and see if you get the same value of K. We should. In my experience, every once in a while it's a little bit off, but pretty close. All right, so I'm going to check this box and send this to our AP Chem folder that you can access from my course page. Hope y'all are doing great, and I'm sure I'll have another video for you tomorrow. Bye, y'all.